Hello, so here's the problem number 3 of a 3-second assignment, and in this problem we have to determine if a given binary tree is balanced or not. So first of all, let's take a look to the definition of balanced. Balanced binary tree, it's when the difference between the height of the subtrees is no more than 1. So for example, let's take a look to this tree first. So we have 3 of 4 nodes. There is a left subtree and the right subtree. The left subtree height is 2 and the right subtree height is 1. So difference is between these heights is just 1. So this tree is balanced because the difference between the heights of two subtrees is no more than 1. And let's take a look to the second example, where we see that the height of the left subtree is 3 nodes, while the right subtree height is just 1, and the difference between two is 2. So, and since it's greater than 1, this tree is not could not be considered as a balanced. It's not balanced tree. So how are we gonna do this? In order to solve this problem, we will call our first of all we will need to define a helper function which will calculate the height of each subtree, and this function will, and in this function each node will be assigned with the 1 value, and whenever we will go, so starting from the bottom of the tree, we will just go to the top a level and calculate the values of a nodes. So for example, here starting from 1, when we go to the upper level, we will add it with the 1 from the upper level. It will give us a 2. Also we will take 1 from the right side, and we will each time we will just compare the difference between two subtrees. So in code it will be look like so. First of all, let's define the helper function, and the return value will be integer. Tree height, the input will be just node, any node. So if node will be equal to null, will return 0. Otherwise, we'll call this function recursively, adding 1 at the beginning with the maximum value of the that we will get from our left and right subtrees. So tree height will be called for left child, and also tree height will be called for right child. And the maximum value will be calculated, incremented by 1. So this one is just to calculate the height, and with this function we will be able to go all over to the last bottom node and calculate the whole height of our subtree. So for example, in this given example, we'll be able to calculate a tree as a result, and our function will return boolean, true or false, is balanced. So input will be not. In this case it's a 3 node. So I will declare two variables, one left for left subtree height and another right. The initial values will be 0 and the right is for the height of the right subtrees. So in case, let's put initial check, like in case our root will be equal to null, we will just return true. So left will be whatever we will get from calling our helper function tree height. In this case we will be calling for the left child of a root, and right will be called for the right. So these two this function will just give us a height of subtrees, left and right. After that, when we will calculate the height of two subtrees, we will just check if math, in our case, we will take absolute value, because we will not be aware of which left or right will be greater than the other side. So I will be just calculating the difference of left and right, and we'll be checking if it's not greater than 1. Also at the same time we'll have to check if there is no difference between left and right child subtrees of our subtree. For example, we will call this function recursively again for our left side of our tree, and the same thing we will be calling for the right side. And if we all the results will be returning true for this definition, at the end we'll just return true. Whenever there will be difference greater than the 1, we'll just return false.